All right, we're going to give a probability distribution for a unfair four-sided dice. So the beginning sentence tells us how it's unfair. It is twice as likely to result in a two than it is any of the other events possible, a one or a three or a four, and the probability of those other events are all equal. So pretty much it's just heavily weighted on the two. And we want to give the probability distribution for the number of twos out of three rolls. So if we think about counting the number of twos out of three rolls, we have three options. In fact, let me move this down and give ourselves space to actually see the three rolls. So there's the first roll, second roll, and third roll. Okay, so if I'm just counting the number of twos, the events that I'm interested in could be zero, right? None of these could be a two, right? I could get a three, a four, and a one. That would satisfy that condition of having zero twos. I could get one two, I could get two twos, or all three of them could be twos. So now let's give the probability of each one. I'm going to space these out a little bit more. 0, 1, 2, and 3. Okay. So we first need to figure out what the probability of a 2 is and what the probability of not a 2 is. So we see how it's unfair. It's twice as likely to result in a 2 than it is a 1, 3, or 4. So if I take the probability of 1 plus the probability 2 plus the probability of a 3 plus the probability of a 4, because these are all the options that I have, I know that when I sum their probabilities together, I should get 1. Now, whatever the probability of a 1 is, let's represent it with a dot. And in the problem statement, I know that the probability of a 3 and a 4 are the same thing. And the probability of a 2 is twice this amount. So let's give that 2 dots. Now, in total, I've got 1, 2, 3, 4, 5 dots. Oh, 1, 2, 3, 4, 5 dots. So 5 dots is 1. So each dot takes up 1/5 of the space. So the probability of a 2 is then 2/5 because it had 2 dots. And the probability of a not a 2 would be a 1 or a 3 or a 4. So it would be the other 3/5 of the probability. Okay, now let's think about our first event possible, the probability of rolling 0 twos. And let's actually write out the events possible. So because I'm just counting the number of twos, I don't really care what the dice rolls, just if it's a 2 or not. So the event of having 0 twos would be not a 2, followed by not a 2, followed by not a 2. Now this occurs with probability 3/5 times 3/5 times 3/5, right? Because each one of these is not a 2 happening, and you need it to happen 3 times in a row. So here we end up with just 3/5 cubed. All right, the event of rolling one head. So the head could be in this position. So that would be a 2/5 probability right off the bat. That's a bad 5. Right, that's the probability of a 2 happening. And then these two spaces are the not twos. So I've got a 3/5 happening, followed by another 3/5. All right. But that's me saying that the 2 has to go in that first spot. So now I could also have the 2 in the second spot. So not a 2, and then not a 2. So I need to add to this a not a 2, a 2, and a not a 2. And I've got one more to think about. The 2 could go in the third spot. So that's a 2, that's something else, and that's something else. So this would be not a 2, 3/5, another not 2, 3/5, and another not 2. So in total, the event of having one head, or sorry, 1, 2, has 3 different simple events inside of it. So this is 3 times a not 2 happening twice, and a 2 happening once, right? Because it doesn't matter the order of all these multiplications. All right, now let's move on to the other event. The event of rolling exactly two twos. So that could be, let's go back up to our picture. We could put the two there and then not a two. So that would be 2/5, another 2/5, and then a not a two with 3/5. All right, we could also have the two in the second spot. So something, a two, and then something else. So that is, oh, I'm sorry, we're doing two twos. So let's have the twos in the second spot and third spot. So this is a not two, followed by a two, followed by a two. And then I've got one more way to do this. If I'm rolling two twos, initially they were in the first two spots and then they were in the last two spots. What if they are in the first and the last? So the not two happens in the middle. So that would be 2/5, a 3/5, and then another 2/5. So there are three ways to do this. We had two twos and one not two. And then finally, our last event of rolling all twos. So the event of rolling three twos, there's only one way to do that. I've got a two there, and two there. So this would be 2/5, another 2/5, and another 2/5, or 2/5 cubed. And I know that's all the events that I'm looking for because if I'm rolling these three times and I'm either a two or not a two, then I've got two options for each spot. Right. So if I have two options for each spot, the total number of options I have is two times a two times a two for 8. And I do think I have all of my 8 here. I've got one here, 2, 3, 4, 5, 6, 7, 8. All right, so those are all the events possible. So this is one way to get the distribution, but what if you have a problem that's a little bit more complicated than this? Or maybe you're rolling this dice more than 3 times, and it gets a little hard to count all of these options. So that's where the binomial comes into play. In fact, what we've done already is a binomial. We just didn't actually use the equation. So the equation is n choose x, the probability of success occurring x times, and the probability of failure occurring n minus x times. And that's exactly what we just did. If we were thinking about x being 0, what's the probability of having 0 successes or 0 twos? It was 3 choose 0, a 2 happening 0 times, and a not 2 happening all 3 times. That number just boils down to 1, right? There's one way to choose 0 items from a list of 3. This just gives you a 1, and you're really just left with 3/5 cubed, which we knew we were going to be left with at the end anyway. All right, now if we think about the event of rolling 1, 2, that would be 3 choose 1, a 2 happening once, and a not 2 happening twice. Well, 3 choose 1, that just boils down to 3. You've got 1, 2 happening, and 2 not 2s, which is what we knew it would be anyway. And then the event of rolling 2 2s, that would be 3 choose 2, a 2 happening twice, a not 2 happening once, and 3 choose 2 just becomes 3. And you get the same thing that you thought you were going to get. And finally, the last event, the probability of rolling all 3 2s. 3 choose 3, a 2 happening 3 times, and a not 2 happening 0 times. 3 choose 3 just gives you 1. And you got what you thought you were going to get. So the binomial is a shortcut to counting these probability distributions when you're interested in the probability of having a certain number of successes.